Hi everyone! So we are now on chapter 3.3, Solving Right Triangles, part 2. With the given diagram, let's go over a couple of terms. There's this thing called angle of elevation, and as you can see, this is the angle formed by the horizontal and a line of sight above the horizontal. So basically, from the ground to the line of sight. And then angle of depression is an angle formed by the horizontal and a line of sight below the horizontal. So this one right here, so basically this way, that is the angle. So when we ask you about what is the angle of depression or angle of elevation, make sure to understand where it's starting. It's starting at the horizontal, elevation moves up, depression goes down, right? Let's take a look at example 1. So a 16 feet ladder is leaning against the roof of a house. The angle between the ladder and the ground is 62 degrees. How high above the ground is the base of the roof? So let's highlight a couple things first. So we have 16 feet ladder. That's how long this ladder is, 16 feet long. And the angle between the ladder and the ground, which is this angle here, is 62 degrees. How high above the ground is the base of roof? So I'd say the base would be, base of the roof is here. And then it's asking how high above the ground. So this is the ground going all the way up to the base of the roof. I'm going to denote that as H. H for height. So we have to solve for H. Before we move on, for these kind of diagram problems, I would actually form a new triangle so that I could see a simplified form. So this way I don't get distracted by other properties. So we have 62 degrees here, 16 here, and then we're looking for H. Using one of the trig ratios, SOHCAHTOA, we need to choose a ratio that would let us solve for H. In this case, the angle we have is 62, and the relative to that, the side that's across from that angle, is the opposite side. Hypotenuse is the ladder. And we don't have adjacent, so we're going to remove it. So what kind of ratio, trig ratio, involve only the opposite and hypotenuse? You can see that we have this, and that's the only option we have. We have to use sine ratio. So let's start with sine theta equals opposite over hypotenuse formula. Plug in all the values we know. So sine an angle is 62 degrees. Opposite is h, like little h. And hypotenuse is 16. From last class, we talked about how to remove the denominator, or how to isolate h. So we multiply 16 to both sides of the equation, and we'll get 16 times sine of 62, and this equals to h. Right, so let's actually plug it into the calculator and see if our answer works out. So we have 16 times sine of 62, and again double check if this is in degree mode and enter it. So we have 14.1272. And it looks like I didn't specify how many decimal places we need to use, so I'm just going to stick to 2 decimal places. And next time for you guys as well, if you're not sure, just write 2 decimal places as well. So in full sentence form, the base of the roof is 14.13 feet above the ground. And that's it for example 1. Moving on to example 2. If a sailor on the deck of the ship tilts her head 30 degrees upward to see the plane, and the plane is flying at an altitude of 3,000 meters, then what is the horizontal distance from the boat to the plane? All right, so I highlighted some key numbers. I'm just going to state it on the diagram. So we know that the sailor is on the ship, and she tilted her head up 30 degrees. So 30 degrees here. So angle of elevation is 30 degrees. And we know that the plane is flying at an altitude of 3,000 meters. So this over here is 3,000 meters. What is the horizontal distance from the boat to the plane? So we're looking for the distance between the boat to the plane, and I'm going to denote this as D for distance. So we are solving for D. Let's form a new triangle, so I could just label the properties we have like that. And this is a right angle here. Because we're solving for D, we need to choose a trig ratio. Let's see, so TOA, and we have, if this is the given angle, across from that angle we have the opposite side, and the hypotenuse we don't know, we have the adjacent side. So we need to choose a trig ratio that uses opposite and adjacent. And it looks like that would be our tangent ratio. So let's write it down. Tan of theta equals to opposite over adjacent. Plug in all the values we have. So tan of 30 degrees equals opposite is 3,000 and adjacent is what we're trying to solve. All right, let's isolate D to solve. Because D is in the denominator, we do have to bring it to the top, to the numerator, and we do it by multiplying that value. So we have D times tangent of 30 equals 3,000. And then we divide tan of 30 again. And understand that you can't divide tan on its own. Tan 30 is a package. It's a function. Okay, so you can't just conveniently get rid of 10 by dividing it. All right, so we're left with D equals 3,000 divided by tan of 30. Let's plug it into our calculator. We have 3,000 divided by tan of 30 equals some big number here, and let's see, I'm just going to write down up to 4 decimal places first. So D equals 4, okay. And then I'm going to round it up to 2 decimal places when I'm stating our solution in words. All right, so D is horizontal distance. So the horizontal distance from the boat to the plane is, this big number with the correct unit meter. All right, here comes the last example. Natalie is rock climbing and Aaron's belaying. When Aaron pulls the rope taut to the ground, the angle of depression is 73 degrees. If Aaron is standing 8 feet from the wall, what length of rope is off the ground? All right, Okay, so here is a question without a diagram. That means we have to set up our own diagram. So we'll start with the ground. And we know we have a wall somewhere here. So I'm just gonna label wall and ground. And I'm assuming Aaron's somewhere on the ground, pulling the rope for Natalie. Natalie's probably somewhere around here, going up, hanging to the rope here. All right, and it says the angle of depression is 73 degrees. So what they mean by that is that angle of depression must have the horizontal and you have to go below that. So we have angle of depression from horizontal down to this side. So this is 73 degrees. And I'm going to denote R for rope. And we know that Aaron is standing 8 feet from the wall. So 8 feet from the wall, here to here. There's two ways to think about this problem. And the first way, or first method, is to use the property of lines and angles. So if we have the angle of depression, let's say our triangle is like this. We only know how to solve a triangle when we know the angle inside the triangle. But the problem is we don't have the angle. We don't have this angle. Okay, so well, you could solve it, but then in a way we're not given. So you're supposed to use the property of angle. So I'm just going to redraw this diagram. So if there's two parallel lines and a line cuts through those two lines, and let's say if this angle is alpha, then there's also this angle from the other horizontal to that line equal to alpha as well. That being said, this angle over here, let's say this is angle beta, then this angle from the other horizontal will be also equal to beta. So this is true for all parallel lines with a straight line crossing it. Okay, so we're going to use this property, and let's actually form a new thing here. So if the angle of depression 73 degrees here, then the angle of elevation must also equal to 73 degrees. So I'm going to set up our triangle that way. So we have 73 degrees, and this is 8. We are looking for R. All right, so before we solve it, I'll go over the second method. And the second method is to just form a new triangle. Without using the property of lines and angles, we're just gonna draw a line straight down, vertical line. So we are going to form a new triangle like this. So our new triangle would look something like that. And because we know that the distance from the for Aaron between the wall and the wall is 8 feet, so I can actually just keep the 8 over there, horizontal distance. And we have 73 degrees as an angle of depression. And we're looking for R. So we didn't have to know the line and angle properties in order to solve this question. You can just form a new triangle. Anyways, same idea. Let's just try to solve this first. Using SOHCAHTOA, we have to have, this is opposite side, we have to have hypotenuse and adjacent in our trig ratio in order for us to solve for r. And that would be adjacent and hypotenuse right here. We have to use cosine. So cos theta equals adjacent over hypotenuse. Plug in all the values we know. So 73 degrees equals to adjacent's 8. Hypotenuse is r. Multiply both sides by r. R times cos of 73 equals 8. Divide both sides by cos of 73. And so we're left with r on the left hand side. I'm going to plug into the calculator. Now, let's see. 8 divided by cos of 73 degrees equals 27.36. R equals 27.36. Okay, so let's double check using the other one, the first method. So angle, the side across from the angle is opposite. We have adjacent here, hypotenuse here. And again, you have to use adjacent and hypotenuse, which is only for cos theta. Adjacent over hypotenuse. So cos of 73 equals 8 over r. So notice that it's the same setup, and even if your triangle doesn't look exactly the same, well, it's technically the same, it just shifted, it just rotated it, but you will still have the same ratio. So your r will actually still be 27.36. Okay, so finally we do have to state it. The length of the rope is 27.36 feet long. So that's it for today. I'll see you guys in the next video.